This is sort of not very rehearsed talk, so we'll see how this goes here. So, how many of you know the Wikimedia Foundation versus just like Wikipedia? You know the difference a little bit there. For those of you who don't, the foundation is the organization that's in charge of running Wikipedia, including a lot of other sites like Wiktionary and Wikimedia Commons, and Wikispecies, and who knows? I don't even know what some of these logos here are for. I don't know what they're talking about, but there's a lot of them. There's a lot of sites. And you probably heard this for the Great Mission Statement. I'll tell you from the inside, they're actually really great. They're a really great organization to work for. I'm very proud to be a part of the Wikimedia movement. Yeah, so I'm Andrew Otto, and I'm a systems operations engineer at the foundation. I work mainly on analytics infrastructure. I've been there since about 2012. And before this, I was working at couchsurfing.org, doing a lot of just like systemic stuff, a lot of MySQL replication and scaling, I guess. So yeah, so Wikipedia is a pretty big website, at least in total numbers of HTTP requests. There's some other metrics we're not as large for as for, like we don't have to do as many database writes as say like Facebook or something like that. But for requests, we have a lot of them. We are the 5th largest website globally, at least according to Camus. There's 500 million unique visitors per month, 20 billion page views per month, and we do a peak of around 200,000 HTTP requests per second. So this is a little graph of HTTP requests per second. It's actually not that accurate. It's a little high due to some really annoying technical monitoring graph reasons, but it peaks at around 200. It averages more like 150,000. Yeah, so that's a lot of requests. There's a lot of really yummy data. So the question is, how do we move that data around? Before I go into it a little bit, I'll talk about some history of analytics and logging and some Wikimedia architecture. So there's 2 main data sources that the analysts at the Wikimedia Foundation are really interested in. Those are the MediaWiki databases, and then these logs, these HTTP request logs for these things. Historically, we've got a lot of plenty of MySQL slaves that the researchers can access and query. This works pretty well for the most part. The data isn't too huge. Some of it's very big. Depends on what you're looking at. If you're trying to look at, say, like the entire revision history of like a popular Wikipedia article or all of English Wikipedia, that gets pretty big. But for the most part, if you're looking at trying to do analysis on types of edits that people make, it's not that big. So you can kind of keep it inside of MySQL queries. There's also these web request logs. So this is just like a log line for an HTTP request that you might use. So IP address and timestamp and the URI and everything else. So as I said before, this can max at around 200,000. I like this graph because you can see the peak there is this year's World Cup final. We had a large peak there. So our front-end web servers are Varnish. Wikimedia relies pretty heavily on caching. Most of the traffic that we get is all read. People are just kind of anonymously browsing PDFs or articles. We would like more people to edit, so we would like it if there was a lot more write traffic, but most of it's read. So we rely heavily on caching. If you don't know Varnish, it's just a front-end cache web server. So all the requests go to the Varnishes and they cache. If they have a cached page, they'll serve it. Otherwise, the request will go to the backend of Apache and communicate with the software. So Varnish keeps what it calls a shared memory log. So unlike, say, like Apache or something, or some other web server where by default it's just writing all of its requests in a log file somewhere on the local server, it keeps a shared memory log, and then other applications can hook into this and read the logs as they come through. So there's one that comes with the Varnish suite called Varnish NCSA, which is just kind of like a standard out format. So it reads these logs in memory, and you can format them to whatever format you want them into a file. A long time ago, before I worked for Wikimedia, we patched this piece of software to have it send logs out through UDP. Actually, before they were doing it with Varnish, they did the same thing with Squid. But basically, yeah, so there's a service that runs, reads all these logs, and then sends them out over UDP to this really kind of not that awesome, but kind of awesome piece of software called UDP to log. This is a custom in-house software that someone wrote a long time ago. And it's just a really simple daemon that listens for UDP traffic, it looks for new lines that delimit messages, and then there's some actually very convenient configuration that you can do to have it tee set that only included requests for a particular content type, or another data set that only included requests to, I don't know, maybe you're geocoding by country or something, you only want to see US requests or something like that. You could really do anything with it. It's pretty useful. It's just a single daemon that runs on a single box somewhere. Somewhere along the line, someone realizes that we wanted to be able to be a little more flexible, and so someone wrote just like a daemon SOCAD relay that listens for this UDP traffic and then sends this out to a multicast group so that there's lots of consumers. There's not that many, but you could spawn more. So this works pretty well, except for it doesn't scale. Every UDP log instance has to see every network packet that gets submitted. So if we're doing like 200,000 messages a second, that means that like this single one server that's like supposed to be like also like processing these logs and sending them out and writing to the disk and doing all these things, also has to like read every single packet that it gets. So in earlier in Wikimedia's history, this worked pretty well, but as the site grew, it didn't really work well. We actually see we have pretty regular loss from this. We average on like around 4%. It hovers between like 2 and 8% sometimes, depending on how busy a box is. Yeah, we just kind of have lived with it for a long time. Like we're like, well, 4% message loss, whatever. It's analytics data anyway. It's silliness. I just wanted to point this out. If you didn't know about it, there is a website called stats.wikimedia.org that is built on a lot of these data sources, so the media databases and some other things, including all of the logs that we're saving via this UDP log software. And it's pretty extensive. There's so many numbers in there. I don't even know what's in there. The way this stuff is generated right now, like I said, it's from the databases and it's from these log files that we save, and there's like some complex pipeline of Perl scripts, and I don't know what else is going on in there, but somehow it becomes this website. There's like one guy who's been working with the foundation for a long time who's been maintaining this. He's been doing a great job forever, but it's hard to scale it. So anyway, so that's a little bit of the history. What we want is to have all of these requests saved somewhere, maybe Hadoop or something like that, for easy and fast analysis. In order to do that, we need scalable log transport. The UDP log thing isn't scaling, we cut it. We evaluated a lot of options when we were making these decisions and decided to go with Kafka, which you're all here for. So I asked Joe this when I was kind of making this presentation. I don't really know what the level of like Kafka experience is here, so I'm trying to give a brief overview. I'm going to take a lot of questions at the end, but you guys can really interrupt me anytime and ask questions if there's anything that you want to ask. These are some pluses about Kafka. It's distributed. Messages are distributed across multiple nodes. It's reliable. Those messages are replicated across multiple nodes, so if you lose a node, you won't lose messages. And it works pretty well. I got the statistic from some LinkedIn presentation that I found online. I don't know if it's current or something, but it's like 20%. Yeah, it's probably way bigger. I was looking something. Yeah, it works. It works great. So I'll go over this stuff. Probably most of you know this stuff, but if not, I'll just go over it. So in Kafka terminology, a broker is just a server. It's kind of like the middleman. Producer are the ones that are sending messages. So in our case, we want to get logs from Varnish, so somehow we're going to have some producer on Varnish system. This could be anything. If you have an application that wants to produce data, there's lots of it. You can do this. And the consumers on the other side, they're reading data out of Kafka. What's nice is that it's end-to-end. Like you can have any number of producers and any number of consumers working with these brokers. Quick little diagram here of a generic Kafka cluster. See these little dots, which means lots of any of these things. Other terms. So in Kafka, a topic is a logical delineation of messages. So if you have different applications using the same Kafka cluster, you can delineate those with topics. So you can say like, oh, my metrics, are going to be in this topic, and my whatever else you send through, your log data will be in this topic. Partitions are an internal way of breaking up those topics that Kafka uses. It will distribute based on the partitions and also replicate those based on the partition level. So it's just like another level of breaking up this logical delineation. So Kafka is replicated. So a producer will send a message to a single broker, and then that broker will have that message, and depending on the replication configuration for that topic, other brokers will then read that message from that broker and save it to this as well. A follower are those other brokers that are replicating from the broker that is the leader. And then Kafka maintains at all times an ISR, so a list of the in-sync replicas. If at any time a particular broker starts to lag for whatever reason, maybe it's serving too many consumers, or maybe it's got a problem with the disk, or maybe it's just down, who knows. Kafka will update this list of in-sync replicas and propagate that data around to all the other brokers so that they, if need be, another one of those can take over as a leader. This list of in-sync replicas will also be propagated to producers and consumers so that they can automatically reconfigure themselves as well. So dynamically, if a broker goes down at any time, the producer can be like, oh, I see this is great. Okay, well then I will stop sending messages to that guy. Any messages that I had in flight that haven't been acknowledged, I will also resend those to someone else. That's configurable as well. You can choose for a particular topic how reliable you need it to be. Like if you were like, you know what, I really want this to be low latency, I just want to send these messages out, I don't care, I don't want to wait and see if they actually get acknowledged by these brokers, you can do that. Or you can have something higher where you're like, I want to know when all of the brokers that are in a replica for a particular topic or partition have this message before I decide that it's been sent to the system and it's not been lost. I mean, that's a really quick like overview of a bunch of like Kafka topics. Before I move on, I guess maybe I'll take a few questions here. Okay. Like, does anyone want to ask any questions about that? Sure.
I guess I had a more generic question. So you evaluated a bunch of different options. Do you remember what the other ones were?
We looked at Flume. We also looked at, I think at the time Scribe we were actually still considering. There's actually, I was thinking about putting that in this presentation. There's a couple of documents that we wrote up on like which one we want to choose. Because like when we're making these decisions, we have to convince everybody internally that we're like making the right decisions too, right? There's always politics about these things. We're like, no, this is great, we should really do it. And we also had this like great spreadsheet of like probably like 12 different things that maybe were contenders and narrowed it down to 3 and actually think, cool. Yeah, any other questions before I go on? I'm gonna start talking about what am I gonna talk about? Yeah, some other parts. I'm gonna talk about Kafka and Wikimedia, that's what I'm gonna talk about. Yeah.
So the topics and the partitions, how those kind of, I know a lot of distributed messaging just have kind of topics and they don't really talk about partitions. Is there kind of a, way of handling this kind of ideology?
Yeah, the partitions are sort of they're an implementation detail in Kafka. From the endpoints, don't usually have to worry about it too much. If you're using the protocol and you're like trying to write your producer or your consumer or something like that, then you would have to worry about it a little bit. But from a higher level, it looks sort of just like, hey, I have a message, I want to send it to this topic, and it goes through. Partitions are used for scaling out a particular type of message. So if you have a message that is traffic or something, you give more partitions, and by doing so, scale out a little farther. You can each partition will be replicated to some number of brokers. Set it up. There's more to it than that too, but like it's mostly like an internal Kafka thing. It's how they deal with replication and distribution and stuff.
I have a question. You talked about what happens when one of the brokers goes down, and my question is, who's responsible to find the other broker? Is it Kafka library, Point library, or is it secure responsible?
It's built into the API. So the producers have a way, Kafka uses Zookeeper right now. Producers don't use Zookeeper so much anymore. Consumers still do. I think they're trying to move away from Zookeeper a little bit, but the brokers definitely use Zookeeper. So they use Zookeeper in order to, do you know Zookeeper? I'm sorry. Yeah, okay.
they use Zookeeper in order to agree on who is actually the leader for these partitions, which replicas are missing. So that keeps the internal, all the brokers in sync together. And then if there's a change, so say like a broker dies or something like that, that information can be propagated through the API to either a producer or a consumer, so that they will be notified of that change. So I'm not that familiar with the API details that much, but it's either that information is sent, Joe can probably tell me what it is now, that information is either sent along the API or the producers are told to, at that point, that they need to make a new request.
There's a metadata request, and you're supposed to implement the protocol. This is part of the project, and use the Apache Kafka API to do this, and it should do this if you use another font library. If there's an error, you're supposed to make another metadata request. And once you make the metadata request, you compare that to your existing metadata, and if it's different, you go with what's different. So it should be extracted from you, like from the API perspective, but like I can't speak to like every font library. Like if you go find a COBOL font library, I don't know about that, but that's how it's supposed to work. It does that for the Apache project, and most other libraries do that as well. I know the code will does that.
Okay, so yeah, Kafka at Wikimedia. So I'm going to talk a little bit about the analytics cluster that we use as a whole. This data that we're trying to use it for analytics purposes, not for application purposes, so that's why I'm talking about it. So we use Hadoop for batch processing. We also rely on Hive a lot. A lot of the researchers and analysts that we have at the foundation are not really strong programmers and they're not necessarily into Java. Some of them are, some of them aren't, it just depends. But everyone's very familiar with SQL, and it's great to be able to have this abstraction on top of data. Technologies, we use these things. If you guys want to ask questions about what these things are at the end, we can talk about that. Hey, look at the diagram of the analytics cluster. Okay, so you can see here these varnishes. These are the web servers in the front end. You can see that I've grouped them into multiple data centers here. We have a few data centers around the world, not that many, just a few, where we receive these things. We're doing something a little non-standard here. I'll talk about this a bit. Kafka, people recommend not to do production across data centers. They don't know the way that you're supposed to do it. They're doing it anyway. And then one of our main data centers, we have this Kafka cluster. We're running with 4 brokers. And then I'm not going to go into detail on this side over here because that's more like Hadoop stuff. We're talking about Kafka. I said this already. We do, So we're consuming this data into HDFS every 10 minutes. We run currently with 4 brokers. There's actually, I think, about 95, maybe almost 100 producers right now. So it scales pretty well. For like, we don't even really need. We could run with, I think, 2. We can go down to 2 and not have any problems with the way things are right now with data that we're serving. Yeah, 4 brokers. We're only using 4 topics for the web request data that I mentioned. It's split up based on the different types of varnishes, different requests for like media files versus mobile, other things like this. And we only have 12 partitions right now. We did that because each of our brokers have 12 disks. It may or may not have been the right decision. It's working okay. We're running with replication factor 3. So producer. So we had a requirement from our ops team when we were making these decisions. We could not run a JVM on the front end varnishes. We hired the author of the librd Kafka client, so it's the C client for Kafka, to build us something called Varnish Kafka. If you remember before when I was talking about that Varnish shared log, that Varnish shared log and this other thing called Varnish in CSA. This is a very similar piece of software to this, except for instead of writing to a file or our version of it, so some UDP socket, this is a Kafka client. So it will read that Varnish shared log and format the messages however you configure it. We're using JSON, and then send those as messages over to Kafka. We're using our main consumer. We have a couple different consumers that we use. Our main one is called Camus. So Camus is just a MapReduce job to do distributed loads from Kafka topics. But the really cool feature of it, there's other like Kafka Hadoop consumers out there, but the really cool feature of Camus is that it's configurable to, you can configure it to know how to infer the
and while doing so, write that into HDFS into a particular bucket. So this is good for us because we want to be able to bucket based on timestamp. So like as data come in, we want to be able to say like, hey, I don't want to like have to query all of the logs just to see like do some analysis. Like if I'm only concerned with data from the last week or last day or last hour, I only want to have to look at that data. Previously, when we were doing the UDP log scenario, we were saving all this data in files. Those files were rotated daily via log rotate, and that can just like run at any time. And then when that happens, a file that gets rotated and compressed then contains timestamps, request timestamps from like if it's named after like July 14th or something, if it's named after July 14th and it's rotated on July 14th, it probably has data from July 13th on it too, because that was the last time it was rotated. So analysts would then have to like factor this in when they were doing it. So they'd be like, oh, well, I want to look up data for July 14th, but I better also consider the files that are for the 13th and the 15th and all these things. So Camus is really nice. This is great for us because of the way we're using Hive. Hive allows you to partition your tables based on directories as well inside of HDFS. So if you, in Hive, if you particularly say like, hey, select the requests where the timestamp, the year is 2014, the month is July, and the day is the 14th, and the hour is 23 or something, it will only read data out of that directory. It's not going to go and look at all the data. So you can kind of like, this also helps when you're prototyping your queries and trying to figure out what you're trying to do as an analyst. You can narrow what you're working on down to a smaller amount of data at this time. This is also, I like this because I'm kind of proud of this little graph. Consuming from Kafka more frequently, if you're doing batch consumption anyway, more frequently is better. Just because it's more likely that the messages that have recently been written to Kafka are in memory. And if they are, then you don't have to hit disk. This is at the exciting part of this graph over here. We were consuming with Camus every hour. This is a graph of bytes read per second on broker disks. You can see that when we're doing per hour, every time Camus ran, there was this big spike of disk reads. We changed doing every 10 minutes, and there's a much lower number of bytes read from disk. Which is nice. Yeah, it's a good thing. We have another consumer that we aren't fully using in production yet, but we do like it. So that UDP to log thing I was talking about before, it creates all these files, and there's a lot of downstream consumers of these files. So that's stats.wikimedia.org website, a lot of other internal consumers. They're all used to getting their files in some format that UDP to log creates. And we didn't want to like do things too drastic and like completely shake up the world by making it like consumed from some like Java-based thing and like read in JSON and do all this stuff when we're used to parsing TSVs. So we also had the author of Wikipedia Kafka write this. It also uses it uses the C client, and it's a drop-in replacement for this UDP log process. Now, it's actually pretty cool. Like, I would not recommend that you guys go out there and like use UDP log. All this stuff is open source. You can find it out there. Don't go use UDP log. But if you're already using Kafka and you want like a non-distributed consumer that is very flexible, kafkatee works pretty well. You can consume from multiple Kafka topics, which is not something that I know of other consumers can really do. And optional sample, optionally reformat the things we want in JSON TSV. It probably supports a couple of those too. And then output to multiple files or pipe processes. So here's read this. Yeah, you can read this. So I'll describe this real quick because I think it's cool. So each of these here is just a JSON field name. And it knows that the input that it's going to read is JSON, so it's going to convert the JSON into this TSV format.
Okay, sorry, and the slash is like the X path of the JSON, so that's like HTTP status and the structure within cache status?
No, that's just the format. That's just the formatting. The old UDP log was local to that. Okay. So cache status is just its own JSON field name, and HTTP status was slash is just a literal slash. Same with the URI. So we've got the different fields, different parts of the URI split up into fields, and we're just rebuilding it back to whatever the old format used to be. But you don't have to do that. You can leave it in JSON if you want to see it. The cooler part are the outputs here. So this one is very simple. You're telling it that you want to output to a file, and you want to sample 1 out of 1,000 messages. So it'll automatically do this. And that's the file type that you can write to. So the one here is outputting to a pipe process, still sampling 1 out of every 10 messages. Here's just some like grep process, so it's just looking for something on the log of different payments. But you could do anything arbitrary, multiple levels of pipes, and it's appending this like that. It's not good if you're trying to like pump tons of data through this thing. It's not really that great because this is like it's not a distributed piece of software. It's going to run on a single box. But if you're not, it's pretty well for doing this kind of stuff. So overall, Kafka has worked really well for us. We've been using it in full production only really since I think maybe June, but we've been kind of running it using production data for over a year now. So like I mentioned before, we are doing this inter-data center production thing, which the Kafka team recommends that people don't do. They recommend not to do this mainly because of latency issues. It's kind of hard to say, like, if you're not in control of the network, if it's not local, and messages produced across the internet, higher latency. We're doing this anyway just because our other data centers are mostly caching data centers. There's tons of these varnishes out there, but there's not really that much other hardware there. And convincing ops that it was worth it to install Kafka clusters in all our data centers and centers. And some of them are full, like some of them all require like getting a new rack or something like that. And these things. And people were like, do we really need to do this for like analytics log data? I think so, but I really don't think so. So we're doing cross data center production. Most of the time it actually works. There are occasional instances when the link provider hasn't been reliable for whatever reason, and we've had drop messages. When this happens, I'd like to say the messages that we lose are not due to the Kafka system itself losing the messages. They are due to back pressure in the producers. So the producers, they're getting all these HTTP requests from the internet, and they want to send all these messages out, all the logs out to Kafka. But if the latency is too high, then the acknowledgement that the producers are waiting for from the brokers takes too long, and the buffers that Varnish Kafka has, where it keeps these messages start to grow. And there's a limit. We don't want to we don't want to use all the memory in this machine, so we have there's some limit to the buffer sizes on these Varnish Kafkas, and if that buffer fills up, Varnish Kafka is going to start dropping messages. So that's why they say don't do it. But it kind of works. If you're doing application data, definitely don't do it, because you don't want to lose messages if you're doing application data. But for like analytics log data, if you're monitoring it well enough and analysts know about it, then it's okay. I've also had some flaky Zookeeper connection issues. This is the connection from brokers to Zookeeper. I'm pretty sure that this is also not Kafka's fault. I think this might be due to some unknown hardware network issue that I haven't yet been able to figure out. But as long as we found that as long as we turned up our number of acknowledgements that was required, we don't lose messages when it happens. So what happens is, if a broker loses the connection to Zookeeper, Zookeeper and the rest of the cluster will be like, hey man, that broker is down, let's take him out. So for a very short period of time, a second or something like that, the Kafka cluster will consider that broker out. Any of these topic partitions that it was the leader for will then, the leaders for those partitions will be reassigned to other brokers, which causes one of these metadata changes to happen. So the producers are notified, and they have to issue a metadata request to learn about the topology of the cluster. When we had acts only at 1, what would happen is those messages that were already in flight waiting for acknowledgement from those producers that happened to go to this one they were received by this one broker that was dropped from the cluster, but it hadn't yet acknowledged anything. What happened is, it had acknowledged these messages to that producer, but since this act level was only 1, the producer's like, cool, I'm going to go ahead and keep sending messages. But at the moment when that broker was taken out, it was not able to replicate those messages to the rest of the cluster. So it came back in a second later, and then its information is different than the rest of the cluster, and the reason it grants itself to the rest of the cluster. And just these messages. So anyway, as long as, you know, X2, if you have like election issues for leaders, we don't see messages.
Just to be clear, that means X, because you're getting a different ACK from each broker. Is that
Sorry,
or is that
yes.
what that?
So this is a producer setting. It's saying like for this particular is it producer setting? Yeah, for this particular topic that I'm sending messages to, or this particular partition, I will not consider this message written to the Kafka cluster until at least this number of brokers have acknowledged it. So I think you might need to correct me here.
So far not.
Huh?
So far not.
So we're not, okay. So the producer is only connected to that leader broker at any given time. So that broker is going to receive the message and wait until that message is replicated to the other broker before it will come back and say to that producer,
And then there's also, you can set the requirements to -1. So that'll be like everything in the ISR has the message, which is like the most reliable, but has the most latency. And in 0.8.2 beta, which is out, which you download, upgrade, and use. Sorry. There's a new feature in there called, you can actually set the min ISR. So now you have the ability to say, I want it to be on all of the ISRs as long as 2 of the ISRs are up. So like for a lot of data, you want to make sure that like data's on 2 racks. You don't want the ISR to shrink to like 1 machine. So you can actually say, I want it to be on all the replicas, no matter, you know, like even though the ISR is going to shrink, but you can't shrink past 2. So there's just a lot more flexibility now. You can set it to 0, and you just get the TCP app. You have no clue what happened. So lots of copies.
what would happen before if,
So for the -1.
no, I guess if, yeah.
So like let's say you have replication factor 3, and you write to Kafka, and 2 of the replicas fall out. Well, there's still 1 left. So -1 still writes to the 1 replica that's left. But in many like use cases for data, that's not compliant. You need to have data reside in more than 1 place in order for it to be like quote unquote saved. So especially in like finance and banking, and like depends on the data, like depends on the transaction. So now you can do that. You can make sure. So what people used to do before that, which is really crazy, they'd write to like 2 different topics and actually statically partition their brokers so that like they were on like all the topics and partitions were on separate racks.
In those cases, how does it usually? I mean, now that we've got the min ISR, what's going to happen? Is it basically these brokers sort of fall out momentarily, and maybe you're just going to wait? I mean, what is the resolution of that?
Yeah, I mean it depends, right? So if the ISR shrinks to let's say 2, and your min ISR is 2, then you're good to go, right? Like it's still going to write data. And if one of those goes out, then the producer's going to get an error saying I can't write it. And then what it does is the producer will retry a configured amount of time and back off for a configured amount of time. So I think the default is 3 times for 100 milliseconds. And then after that, it will just do an upstream, I failed, right? But you want failure sometimes, right? Like you want to be like, hey, this transaction isn't getting saved. Sorry, like I can't process your ATM transaction, right? Like, right? Yeah, so there's that.
Free. We're really only using Zookeeper for Kafka right now.
Is your stock on that?
I mean,
I've seen that issue.
okay.
It's one of like 5 things.
Yeah, I
or
mean,
maybe a new 6 that hasn't been seen before.
okay.
Well, I'm gonna talk about it.
Could that be causing my flaky Zookeeper issues?
So swap could do it. GC pauses could do it.
GC pauses.
It could be GC pauses in the broker as well. So either GC pauses in the broker, swap, or GC pauses in Zookeeper, or just general latency on the disk of your Zookeeper. Lots of possible Zookeepers.
I'm gonna ask you more about
Yeah,
this.
you can also bump your session expirations up from 6 seconds.
I've
tried
tried.
and separate something Zookeeper.
Yeah.
Figure it out.
Yeah.
Probably.
Okay. I guess, yeah, I'll go through this. Some other tooling that we have around Kafka that's kind of useful. So we use a thing called JMX trans to get all those graphs I'm using, or using that. So it's a daemon that has a configuration language that tells it how to query a JVM to get all the stats, and then it knows how to transform those into whatever format a lot of different monitoring tools are using, So you can pull from JMX and then send to Ganglier to Graphite or to StatsD or something very similar. We use all three of those things at Wikimedia, but when I was setting this up, we were mostly using Ganglia, so that's why I throw out Ganglia stuff. Oh, yeah, so Liberty Kafka has this really convenient way of getting metrics out of it. You configure it to write to a file, and it will write, I think there's some callbacks. If you're writing C client, you can like tell it to do it however you want, but it'll, in our Varnish Kafka stuff and in kafkatee, it will write JSON to a file every some 15 seconds or 60 seconds or something. We then just like tail these files and parse the JSON and send that stuff out to Kafka. I like this graph because there's so many colors in it. This is number of messages queued in Varnish Kafka at any given time, so this is measured per second. It's an average across the polling period in Varnish Kafka to get this metric. But I like this because there's like 95 of these Varnish Kafka producers, and we're using 12 partitions, and there's 4 brokers, so there's a lot of data points. It just looks crazy. That's another big graph there of Varnish Kafka stuff. Oh yeah, so Kafka's build system is now Gradle, and it was previously, when we started using it, it was SBT. And Wikimedia is they're pretty strict on how things are deployed in production. Pretty much always we have to deploy via Debian, and making Debian packages and Java build systems hang out together is really difficult. It's really hard. There's also a particularly strict requirement that I think the Debian organization has made as a policy for good Debian packages, and that is that at build time, those packages are not talking to the internet to get whatever dependencies they have. So this is completely different than the way Java does stuff. Java is like, yeah, I'll talk to Maven Central, and I'll talk to, you know, like whatever else is in here, and the Apache people have some stuff, I'll get that too. But we can't do that. We're not allowed to do that. So it's very frustrating. So we ditched it. I tried to make it work for a long time. I was like, okay, these Debian things, and make Maven, I don't know, something. And I'm also like, I'm much more familiar with Maven and sort of like Java packaging now, but this was like 2 years ago, and it was not at all. Neither was I familiar with Debian packaging. I don't know what is going on here. So we had some other guy who's like really good at just Debian files in general, kind of like bang his head against SBT for a while and make custom make files. So we built Kafka via make files. So it's a nice little Debian package. It includes init scripts and there's configuration. I like this. I think all the little scripts that ship with Kafka are really annoying. There's all these little .sh shell scripts that ship with Kafka. I wrote a single shell wrapper. I also did this so I didn't have to install like 20 different scripts with the Debian package. I just install this one thing. And it's just a wrapper around. There's one shell script in there called Kafka run class that knows how to like shell out to Java and pass the proper arguments in. And I just made it so it's just one script rather than a bunch of them. So you can see in here there's the console producers, things that ship with Kafka. If you're doing a local cluster, you can start your own Jupyter server locally. The topic ones are most useful to look at the states of the ISRs and create topics and do a controlled shutdown of the cluster if you want to turn off a broker or something. I do a lot of Puppet work. We use Puppet for configuration management at Wikimedia. So I have Puppet modules for all these things. This one works with the Debian package I was just talking about, but you just write this configuration down and include that class in all your nodes, and it will automatically set up in Kafka. Works for Mirror. Kafka Mirror Maker is the solution for the inter data set of production stuff that they recommend using. We're not actually using this, but maybe somebody is. I think Yelp is using this stuff. They're actually using this Puppet stuff and the Debian package. They send upstream patches to both these things to me, so it's kind of cool.
I think I'm using it.
What's that?
I think I'm using it.
Who's using it?
Yo.
Where are you? I can't even.
Hi.
Oh, hey, there you are. I heard your voice.
Yeah, I'm principal dev.
Oh, awesome.
So that's the second time that we really got that confused. I was the first one. We the second.
Oh no,
No, I think-
Yelp may be using it.
Oh, yeah.
No, Yelp is using it too, but Yelp's using it. You're using the package and the Puppet
I
module?
think I ended up repackaging it because
Yeah.
our packaging requirements are different.
Yeah.
Same.
Cool.
We're actually rewriting the CLI for 083.
Oh yeah?
completely, and we're moving all the administrative functions back to the server. So there's going to be an API request, and it's all going to be server command line protocol calls with the CLI wrapped in front of it.
Okay. Cool.
Yeah, just because it kind of sucks now.
Yeah.
We're writing details.
Okay. Yeah, and so there's Puppet modules for Varnish Kafka and kafkatee we talked about.
I just put that there. Yeah, that's my last slide. Questions? Yeah.
How many topics do you have?
Just 4 really. For topics. We are really only pushing these HTTP request logs through this system right now. We're not using it for application stuff. We're very soon going to start using it for some performance metric stuff. So someone's building sort of like I think a JavaScript client to send browser performance statistics through Kafka. And that'll also go through Apache Kafka as well, in a slightly different way, and that'll be a different topic, and we have to talk about like what that topic is and what partitions it needs and things like that. But we have 4 topics, but they kind of act like a topic. They're all the format in each of the topics is exactly the same.
How are you talking about new and how you studying the timestamp from the
So Camus, it's open source by LinkedIn, but it's not like it's not like Kafka where it's like they spend a lot of time like making sure it's really great. It's just like they have some team and some guy who's like working on it and it's there. So it's not very well supported for outside stuff. I think they're using mostly Avro as their message format inside. So Camus, when I first came to it, really important with that. So you set a Java property that says how to read, say what class you're going to use to read these messages, and that class can be configured to do something else. So like maybe the arrow floating or something like that. So then it knows how to look for that, it will parse that timestamp, and then the rest of the framework is the part you have to modify. So the rest of the framework is just say like, hey, this message has this timestamp, and then it will know what to do with that message. Since we're using JSON, I had to write a JSON record reader for Camus, just so it would know how to read a JSON and look for the timestamp.
Are you using Sweeper?
We're not using Sweeper. I've looked into that a little bit, but not very much. We actually, this maybe the ETL phase over here. So we're bringing all these logs into Hadoop. We don't keep them for a long time. Right now, we're only actually keeping them for 30 days, so it's not that much. We're doing this really because Wikimedia has some pretty strict privacy policies. We're not allowed, this is like completely different than I think like every other organization that's out there, but because we're such like a goody two-shoes organization, we don't keep IP addresses and user agents and things like that for a long time. I think the official privacy policy says no longer than 90 days, but the intention here is to take that data after it comes in and then run it through a bunch of other batch processing that will like geocode it and clean it, do whatever it's supposed to, whatever else we want to do to it, and then save that back in JS. And when we do that, it'll probably be in a completely different format. It's probably not going to be JSON anymore. Maybe it'll be Avro, maybe it'll be stored in Parquet files in some column format. I don't really know yet. But we're not really doing that yet. Right now, we're just bringing it in and say 30 days ago. Yeah.
Do you share your logs across multiple applications, or is it basically just intermediate step before you guys can get to
Like, are there more consumers?
not necessarily. Like more yes, more consumers, but in the sense of applications, not in the sense of
Not so much. We're really only using this for analytics log data right now. I think that could change in the future. But I would really like to have a more generic sort of like logging endpoint for like the type of application metrics that are out there. So when people are building new features and mobile apps and things like this, that they can use this system to get metric data in. If we were going to do actual application data, probably we would set up a different cluster for it so that we don't sort of like conflate the two purposes. Because I think they have slightly different configurations that we want to set up for different ways to scale.
So you have a batch of the vacuums everything from brokers and this, but how much data do you transfer or use for the job?
That in here. I don't know off the top of my head, but I can pull it up. I think I had it in here when I was doing this.
The fact that you said that each broker has a line list or something like that, tells you it's probably a lot of stuff.
Yeah. So
our message size is about, I think that's the uncompressed size. I'm not actually, it probably isn't. That's probably compressed. 30 megabytes per second for producing. I'm going to say that it's compressed because some of this talk I wrote like months ago for an internal talk, and that number I probably also got off of Ganglia, and that would be compressed after the producers compress it instead of the converter. So that's, and we're only consuming this data once right now. Like to answer your question a little bit, we really are only doing it with Camus. We're doing a little bit of that kafkatee thing for some like random ad hoc stuff, but it's not really in production yet. So whatever we're producing, we're also only consuming once.
Analytics data pipeline, you just wonder, is this like the majority of log flow that would be, or is there logs from all the places that
There are some other ones. They're not as large as this one. This is the biggest one. There is another one that's sort of a custom in-house solution built on top of Zero-MQ that we call it no logging. And it's a little bit of this generic thing, but its pipeline is mainly meant to bring slightly generic application type metrics and kind of funnel it through a system so that it eventually gets into MySQL tables and has different feature teams can use that data to do something. But I think actually we should have like replace that system with this system. We'll see how it goes. Huh?
Is MySQL the final resting place for all the raw data out of HDFS, or are you using other tools to do the visualization?
Yes and no. We're not doing very much exporting outside of HDFS yet. The things that were in this this chart or diagram, yeah, like this part here, we're not actually doing that yet. A lot of this stuff on the Hadoop side is like sort of like, yeah, it's kind of happening. It's kind of like prototype happening, but like, it's really hard for me to kind of like get people into this in the foundation. People are kind of like really used to using SQL and stuff, so it's like hard to like. So, yeah. But a lot of it, if it gets small enough, if we aggregate enough, it'll go into MySQL because people are used to that. But it might go into other things as well, where we're setting cluster for some other stuff, and we want to do something there. I would really like to one time do some more real time stuff. I would use batch and send it over that.
How far behind are those all the logs?
Before this stuff happens?
You said you have like 10-minute batches that you're returning?
Yeah.
So by the time it gets to
Okay. Yeah, so we're importing every 10 minutes into HDFS. We use this job scheduler in Hadoop called Uzi in order to figure out when we should launch jobs based on the existence of data. So I think the way we have it set up right now is we wait an hour or two beyond when we think that, like, I think we wait for like 2 hours. 2 hours after some time happened, we'll run the job for that time. And this is mainly, we probably could do it in an hour, or we could probably do it once we start consuming the next hour, because then we're like, oh, we're in this new hour, we've probably gotten all the data for the old hour. But we don't need it that soon, and we just wanted to cover the case where, say for some reason there's, like, maybe Camus hasn't been running for, maybe it's not running on a particular thing for a little bit or something like that. If we were to consume later, and we had already launched a job that had already processed that data, there would be more data inserted into the hour after the job had finished. So we're doing it in about 2 hours.
Do the Hadoop cluster sync with each other? Is there data selection?
Yeah.
What do you, I know it's not Kafka based, but for the ETL phase, what are you guys using to actually cover ETL?
We're not doing a lot of it right now, but it will be a lot of Java and Hive. It'll probably be a lot of Hive actually. It'll be some custom VDFs and Hive, or either just like package Java stuff. Yeah.
I don't know, as a user of Kafka, are you almost reading Scala? Is there much, is it subset much, or
definitely something I would love to talk about when things are not being recorded. But I'll say the recorded version. But in general, so I think my 32 number was like my budget for taking folks out afterwards and getting the first round was 32. So as long as we've got less than 32 people here and someone has a place to go, first round's on me. If you have more than 32, then Josh lost. But anyway, like from the Apache project perspective, like Kafka is fundamentally built to be completely agnostic to any language, right? The broker, from your perspective, unless you want to go and contribute to the code, it doesn't really matter what the code is written, right? So like everything goes over a very custom wire protocol, and we had lots of debates back in the day about whether we were going to change that to use like Thrift or protocol buffers or whatever, and we all agreed not to do that. It's all socket level bytes going back and forth with like a very nice large wiki about how that works, right? And which has been great because there have been client libraries written in C, C++, Python, Go. There's like 3 JavaScript libraries. I don't know which one's best, please don't ask me. There's one written in PHP. There's one written in Go. There's one written in Clojure, right? So from a development perspective, like if there's a language that you use, there's an Erlang one, right? If there's a language that you use that doesn't have a client library, you can go and write it, right? Just as long as you can talk to sockets and byte buffers. From the big data Scala perspective, we can talk about that there.
Yeah, I don't have to touch it at all. The consumer that I most have to deal with is the C ones. So I have done some little bit of hacking of the C library.
I've heard really great things by end users for the high performance C library.
What version of Zookeeper are you using?
What's that?
What version of Zookeeper are you using?
We're using whatever is upstream in Ubuntu or Debian. I think it's 3.4.5 right now, or 3.3.
There's a session bug in 3.4.5. It actually does.
What is it in 3.3?
It's in 3.4.5.
I think
So if you're using the Zookeeper in 3.4.5, there's
Yeah.
a session bug that does disappearance.
Interesting.
I'll find the ticket if you go
Okay.
Yeah.
I think I've seen
that-
that and it wasn't it.
That's
That
number.
sounds familiar.
If you use like the Hortonworks or Cloudera version, their 3.4.5 is patched for that thing.
I've seen this. Yeah, let's talk about that.
Yeah. there's still one other possibility.
Yeah.
That was the other one.
I guess there's no more questions. Thanks everybody.